Ask a normal AI a tricky, multi-step puzzle and watch what happens. It answers instantly and gets it wrong. Now ask one of the new reasoning models. It pauses. It thinks for a few seconds and it gets it right. Same kind of question, same underlying technology. So what is that pause actually doing? And why does thinking longer make an AI smarter? For years, there was only one way to make an AI smarter: make it bigger. More data, more parameters, more training. But around late 2024, a second, totally different lever appeared. And it doesn't touch the model's size at all. You just let it think for longer. At the moment you ask. That idea is called test-time-compute. And it's what's behind models like O1, O3 and DeepSeek R1. Let's unpack it. Why instant answers fail? Remember how a language model works. It predicts the next token immediately. For the capital of France that's perfect. The answer is one confident step away. But for a hard problem, a logic puzzle, a tricky piece of math, committing to the very first word with no working out is a disaster. It's like being forced to shout the answer to a hard question the instant you hear it. And humans don't do that. For anything hard, we scribble, we work through steps, we check ourselves. The model has no scratch paper, unless we hand it some. And it turns out, the way you give a language model scratch paper is beautifully, almost embarrassingly simple. There's a famous way to frame this. Psychologists split human thought into two systems. System 1 is fast, automatic, instinctive. What's 2 plus 2? System 2 is slow, effortful, deliberate. What's 17 times 24? A normal language model only has System 1. It answers on reflex. Reasoning models add System 2, the slow, careful mode. And just like for us, that's the mode that handles the genuinely hard stuff. Step 1. Chain of thought. You just ask it to think out loud. Add. Let's work through this step by step. And instead of blurting an answer, the model writes out its reasoning, one step at a time. And here is why that helps so much. Each step it writes becomes part of the input for the next one. The reasoning literally builds a path to the answer, token by token, with each token standing on the ones before it. The effect is dramatic. On hard math and logic, a model that reasons step by step can jump from mostly wrong to mostly right, with no change to the model at all. The thinking is the scratch paper. More room to work means fewer careless mistakes. This simple trick was the seed of the entire reasoning model revolution. And watch what good reasoning actually looks like. Step 1. Set up the problem. Step 2. Try an approach. Step 3. That gives a strange number. Let me check. Step 4. Spot the slip. Back up and fix it. Step 5. Arrive and verify. Notice the backtracking, the willingness to be wrong mid-thought and recover. That's not a flaw. That is the entire skill. The big idea. Test time compute. Now zoom out, because this is the key insight. There are two completely separate places you can spend computing power to get a smarter answer. Train time. The months of expensive training that build the model. Once upfront. And test time. The compute spend the moment you actually ask. The model thinking, right then, before it replies. For a decade, almost all the gains came from scaling train time, bigger and bigger models. Test time compute is the brand new axis. Keep the model exactly the same, but let it think longer. Generate more reasoning, explore more options, and the answers keep getting better. You're buying intelligence by the second, at the very moment you need it. And that's a genuinely profound shift. A smaller model that's allowed to think can now beat a much larger model that answers on instinct. Intelligence isn't only baked in at training anymore. Some of it is summoned on demand, when the question is hard enough to deserve it. You can even see it on a graph. Hold the model fixed and plot how accurate it is against how long you let it think. The curve climbs. A little thinking helps a lot. More thinking keeps helping, with gentle diminishing returns. For the first time, you can turn a dial, spend more seconds, get a better answer without retraining anything at all. How do they learn to think? So how do you get a model to produce genuinely good reasoning instead of just longer rambling? Reinforcement learning. You let the model attempt hard problems, generate its chains of thought, and you reward the chains that reach the correct answer. Do that across millions of problems, and the model gradually learns, on its own, to think in ways that actually work. And what emerges is striking. Nobody handcodes the strategies. The model discovers them, breaking a problem into parts, double-checking its work, and the big one, backtracking. It will literally write, wait, that's wrong. Let me try another way. That self-correction was never programmed. It was learned simply because it led to right answers. That's how models like O1 and DeepSeek R1 came to be. Thinking wider, not just longer. The newest models add one more trick. Don't just follow a single train of thought. Explore many. Faced with a hard problem, a model like O3 can generate several independent chains of reasoning in parallel, each one trying a different angle of attack, instead of betting everything on the first idea. Then a verifier checks them, hunting for the one that's actually consistent and correct. And that's the answer you get back. It's the difference between one person puzzling alone and a whole room of people trying different approaches while a judge picks the best. Thinking wider, not just longer. And it's how these models cracked problems that had stumped everything before them. One detail that surprises people. You usually don't even see the real thinking. Models like O1 reason privately, behind the scenes, and show you only the polished final answer, sometimes with a short summary of the steps. The hidden chain can be far longer and far messier than what you read. The deliberation is completely real. It's just mostly happening backstage. Thinking isn't free. But all of this thinking has a price. Every reasoning step is more tokens generated, so a reasoning model can be far slower and far pricier than a normal one. A question a fast model answers in half a second might take a reasoning model 15 seconds, and many times the cost, as it grinds through its long, hidden chain of thought. And there's a subtle trap. Thinking does not always help. For simple questions, forcing a model to deliberate can actually make it worse. It overthinks, second guesses a perfectly good first instinct, and talks itself into the wrong answer. More thinking is not always more, right? Sometimes, the reflex was correct all along. So when should it think? Here's the rule of thumb. Reach for a reasoning model when the problem genuinely has multiple steps and a checkable answer. Hard math, competitive coding, complex planning, careful analysis. That is exactly where thinking longer pays for itself, many times over. But for everything else, quick questions, simple lookups, casual chat, light writing, use a fast model. It's cheaper, it's instant, and it's just as good. The real skill, more and more, isn't picking the smartest model. It's recognizing when a question is actually hard enough to be worth the wait. Concretely, debugging a nearly function, planning a multi-step project, working a hard proof, careful data analysis, send those to a reasoning model. What's a synonym for happy? Summarize this email. What time is it in Tokyo? A fast model. Every single time. Match the engine to the road. So that little pause before a reasoning model answers, that's not a delay. It's the whole point. It's the model doing exactly what we do on anything hard. Working through it, checking itself, trying again. We spent a decade making models bigger. Now, we're teaching them to stop and think. So the next time an AI takes a few seconds before it answers, you'll know it's in stuck. It's reasoning. Buying a better answer, one thought at a time. Subscribe for more such intuitive videos